We are going to assemble the hex project. So new, assembly, and my insert components and start command when creating new assembly would automatically come up if that were checked. Since there's nothing open in the background, it's going to launch and go to the last folder. So we'll go ahead and insert the hex body. And by selecting the checkbox, it's going to put it origin to origin. I don't need to rotate, otherwise I would use the rotation or the right mouse button to be able to get it a little closer to where I want it. Alright, so that puts it in position. And being that there's only a couple pieces and we're going to introduce the toolbox, this is not going to be a very extensive assembly, but we do want to explore some of the limitations, advantages, limitations of the cosmetic thread and the thread wizard. All right, so put that in place. Would like to be able to see it. Would not like to drop it somewhere where it pretty much disappears. So going to pick my geometry and we'll go concentric. And I don't want to lock the rotation because I want to see what this is going to do. So if we do a section view, we can see, but this is just a visual. So if I bring this down, I can kind of rough position it to where we can see the thread alignment and our numbers start to work out. And you can tell from the base that I really didn't need these last 2 or 3 threads. So that would help us make the decision on our relief at the bottom. The alignment looks good there. So pretty much would want to consider, we had the 21.5. Let's see, do I have, all right, so we were 25 from the top with 5, so we were 20 to the top of the groove. So here I go doing math again, and we're 21.5 to the base. So if I do that math, 25 minus 5, 20 plus 2.5 for the width would put it on center line with the screw. So that means there should be about 1 millimeter of clearance. So if I zoom that around, I can go into the distance, put in 1 millimeter, and hit OK. And I go back to the section view. This is going to be able to turn, which is going to be a little bit strange for a section. But again, I get to this point and I look at the rotation. The threads are going to line up pretty much wherever they line up. It's not going to engage. It's not like a mechanical fit. So I turn the section view off. That it doesn't give me the full benefit of the for one piece. So one of the things I would consider, and this will also be something that might help in the drawing, is I'm going to expand out so I can hide, and kind of a quick way of doing the hide and the transparency, so we can manage some of those visuals. But really what I want to get to is an assembly sketch, and it's going to warn me that I'm in an assembly context sketch, but I want to be able to slice this this piece but have it only occur in the assembly. So from my sketch and assembly features, this is going to be an extruded cut. We're going to tell it to go through all. I can tell by the direction of the arrow that I need to flip the side of the cut, so if I can get the arrow to flip, then the checkbox. If I do the checkbox, then the arrow. So either one of those will complete the process. All right. So one of the things with a tap, and even at the M20, I would consider tapping this for ease, is it's going to have that 2 or 3 thread lead. So 80 to about 200 thousandths, or 2 millimeters to about 5 millimeters, is going to be incomplete threads with a tap. We go to a bottoming tap, then we could count on maybe 1.5 threads. So you can call it out on the drawing, but really we need to come up with a number that, as a machinist, it drives me crazy when the threads are to the same depth of the hole and I know I can't get there. So, all right, we turn this back on and show our piece. And inside of the cut extrude, I did not select bodies. So let's scroll down, and the hex screw is selected as well. So I want it to be and remain whole, so that as I make the rotation, I can kind of line up those threads somewhere. And again, this is more of a visual than anything mechanical that we're trying to do. So that gets it pretty close. It looks nice. And this would be more of a graphics type deal than anything functional. All right, it would also check that if we were going to 3D print these, that there's some clearances, and we'd have to make some adjustments further on to kind of further define these. So I've got this close. I'm going to go ahead and lock the rotation, and then I can suppress the cut, and we'll go on to the toolbox. All right, so with our toolbox, we're going to the design library, and if your task pane suddenly disappears for whatever reason, we're going to go back over, let's see, user interface and task pane. So it also shows up, and where I think it accidentally gets turned off is on the toolbars. There is a checkbox, and also the view heads up. If either one of those gets unchecked, just clicking through things and I happen to grab the wrong one, that's where the task pane is going to go away. All right, so under the task pane, the design library, and the toolbox, I'm going to add in now, which is the same as coming up to the SOLIDWORKS add-ins and telling it to turn on the toolbox. But usually, if I'm doing a lot of assembly, I will have it from the add-ins load with each session, but for the most part, I only load it when I need it. So we're going to pick the ANSI metric, go into the machine screws, and it was a hex head. All right, so have to look these up, but pretty much going to work into, if our hex bolt goes down to an M6, we'll try that one, so no matching size. So in our library, we're going to double check and make sure, and it does go to an M6, and the designation is by 10 millimeters. It does not go short enough, so that's the kind of the issue, is that would be a little on the long side. And I'm pretty sure there's a way to, oh, no, 18, no, still not. All right, so that's a partial. So that one's not going to get it. A hex cap screw. So these are going a little bit shorter. I might could get away with a 12. Oh, it would help to switch. All right, so an M6 by 10, thread length of 10, and then we'll go ahead and accept that. And then it's going to continue to add these until we X out of it. So my mate relation is going to find the cylinder and put it in place, a right mouse button. If you saw that little check mark on the mouse symbol, that means I can complete it there. All right, so getting this in position. Let's go ahead and unsuppress so I can see the interior. The groove is 6 millimeters and the bolt is, or the groove is 5 millimeters and the bolt is 6 millimeters. So it's only going to come into contact at those locations. So what we end up with potentially is that we would either turn one of these bolts down to have a little bit of a relief to go in and contact if it needed, or if this is just to position, well, I wouldn't want to, if it was a little bit higher, I wouldn't want to contact the threads, because once I deform those threads, it's going to be very difficult to run it in further, and if I do get it to go in further, it's probably not going to come out. Right, so we need a rough position that will contact, it goes into the groove, and since I don't have really all of these cylindrical shapes, I'm going to try to dimension between the planar surfaces. So we'll go to a distance. It's showing at 20.1, so let's just see what 20 looks like. Right, so still a little bit of clearance there. And then that face and the right plane will go to distance and 20 there. All right, so that gives me the mates. It also gives me a full piece. At least these will be able to rotate. Now, I do want to mention that in the options, we have under our Hole Wizard settings that we can lock the rotation on new concentric mates to toolbox components. And where I ran into some issues with locking the concentric mate was in the bearings on the final from the last couple of semesters. That if I was doing a lot of these hex screws, then yeah, on the hex screws we're going to see those. But any of the other components, you want to be aware that it's doing that in case the assembly, the dynamic, even some of it's going to affect the static portion, and have some limitations to anything that is automatic has a comes with a warning of it may be fast, it may be easy, but chances are it's not always going to do what you want. All right, so I just saved this as the hex assembly, and we're ready to do an explode to prepare this for our drawing. And so I do want to go ahead and set a configuration. All right, so the display states are going right now should be set to one overall display state. If I link it to the configurations, then we're going to be able to set colors and views. So I think I want this to be something that I can hide show various components. So I will go ahead and add a configuration, and this one's going to be my partial section. All right, so I can't really do this out of the drawing. I have to kind of do this assembly cut, and then on the default we'll go back and make this suppressed. Right, and what I might do, let's see, for the partial then is also hide these. So if I do the control select, I can hide from here. If I do the flyout, then I'm just going to be clicking those two items. So I can check my configurations and my display states that those are doing what I expect them to do. I'm going to add the, zoom out a little bit, looks like my shadows are turned on, so I will turn the shadows off. And if you have the real view turned on, you will get the nice shiny materials and reflections and everything, but I often call those disco, that until you need them, leave it off. It's just horsepower of the processor that it doesn't really need to use. All right, so my exploded view, we're going to pull the hex screw out, and we'll see what 85 looks like. Pretty close. Let's go ahead and hit done. We'll bring that out. Would like those to be even, so about 20 looks good. Looking for the done, not the okay. And we'll bring that out the same 20. And save this one more time. Right, and then our explode, the default. Double clicking on the explode collapses, double clicking expands, and my partial section, I have all of those set up now to make the drawing. Okay, and then I just happened to think that I would like to have a configuration with the cosmetic threads, so we can go back and set those items. But I did not set up the configurations for these. So in the assembly, we have to have configurations that we can pick. So I need to maybe make a solid threads, and a lot of times I name these just to get them started. All right, so if I suppress this, I should see that as the default. And I'm not seeing my cosmetic thread, which means that I did not turn that back on. So we need to show that one. And we'll double check that's there. And when I save it, now I come back and I'll be able to see that we have those generic generic parts. So when I open, or the generic threads. So let's add a configuration for solid threads there as well. And I'm going to switch back to the default. And under the default, we're going to identify the thread, suppress it, go into the revolve, show it. And if I'd done this while I was making the parts, not always going to be able to determine what I need for the assembly. Go to the partial section, and it's still in that same state. So I'm clicking on the part, and it's set to just this configuration. Go to the solid threads, and apparently that didn't work, so I did something. Oh, it's still... Alright, so partial section, I'm just double checking up here. Partial section, the hex body, oh, I didn't apply it. Solid threads, make sure you hit that checkbox, and then solid threads, and hit the checkbox. All right, now I can check. All right, so this, like I said, this is more of a graphical use of the geometry, and this is the practical side. All right, so I'm going to save it one more time, and now we're ready for the drawing.